DeepSeek's logic. Executive summary. DeepSeek's logic is a philosophy of elegant efficiency over brute force. It uses a mixture of experts architecture, activating only a small fraction of specialized professors for each task, and multi-head latent attention, which compresses memory to enable long context processing at a fraction of the cost. Its training logic prevents bottlenecks, encourages long-term planning, and, through pure reinforcement learning, enables complex reasoning like self-verification to emerge spontaneously. The result is world-class AI performance achieved with dramatically fewer resources. Article: Imagine you're trying to solve a massive 10,000-piece jigsaw puzzle. A traditional approach might be to dump all the pieces on the table and start scanning every single one to find two that fit together. That's slow and exhausting. A smarter approach would be to first group all the pieces by color, sky pieces here, grass pieces there, and then, within the sky group, only look at pieces with a similar shade of blue. This smarter, more efficient strategy is the core idea behind DeepSeek's logic. DeepSeek isn't just one AI model. It's a family of models developed by a Chinese AI company. Their logic, which has shaken up the tech world, isn't about a single magical trick. It's a collection of brilliant engineering decisions that work together like the gears in a Swiss watch. The two main pillars of this logic are an incredibly efficient architecture called Mixture of Experts, MOE, and a revolutionary training method called Multi-head Latent Attention, MLA. Let's break down what these high-tech terms actually mean. Pillar 1. The team of specialists, Mixture of Experts. Think of a large traditional AI model as a single genius polymath. This one brain has to know everything: Shakespearean literature, quantum physics, how to code in Python, and the recipe for a perfect sourdough bread. For every single question you ask, the entire polymath brain fires up, using all its knowledge and consuming massive amounts of energy. Even if you're just asking for a simple cookie recipe, this is incredibly wasteful. DeepSeek's Mixture of Experts, MOE architecture takes a completely different approach. Instead of one giant brain, it's like a huge university with hundreds of specialized professors. You have a professor of poetry, a professor of particle physics, a professor of French history, and so on. At the head of the university is a brilliant but simple gatekeeper, or router. Here's the logic in action. 1. You ask a question, explain the rules of chess. 2. The gatekeeper, router, analyzes your question. It's a very fast, lightweight system that doesn't need to understand the deep meaning, just the general topic. It quickly determines. This is a question about games, strategy, and rules. 3. The gatekeeper then selects only the 2 or 3 most relevant professors from the hundreds available, say the professor of game theory and the professor of rule-based systems. 4. Only those 2 professors are activated. They do their work, formulate an answer, and send it back to you. The other 300 professors didn't even know a question was asked, saving an enormous amount of computational power and energy. This is the first part of DeepSeek's genius logic, conditional computing. It means the model only uses a small fraction of its total brain power for any single task. In DeepSeek v3, the most famous model, there are a staggering 671 billion total parameters. Parameters are like the model's neurons or synaptic connections. However, for every single word it generates, it only activates about 37 billion of them. That's only about 5.5% of its total capacity being used at any one time. The analogy of the managed team. Imagine you're the CEO of a global company with 671 employees, but you only call about 37 of them into any single meeting. The meeting about a marketing problem only needs the CMO and a few marketing experts. The meeting about a software bug only needs the CTO and a few top programmers. You don't drag the entire company into every meeting. The result? You get highly specialized expertise for each problem. Your meetings are faster, and your company's electricity bill and office space rental are a fraction of what they would be. This is how DeepSeek achieves such incredible efficiency, making it far cheaper to train and run than monolithic models like early versions of GPT-4. Pillar 2. The super efficient note taker, multi-head latent attention. The second pillar of DeepSeek's logic deals with how the model remembers context. When you have a long conversation with a standard AI, it has to keep every word you both have said in its immediate high-speed memory, called the KV cache, so it can refer back to it. As the conversation gets longer, this memory cache balloons in size, eating up precious high-speed RAM and ultimately slowing everything down. This is where multi-head latent attention, MLA, comes in. It's a sophisticated form of data compression. Let's go back to a 10th grade classroom. Your history teacher has given you a 10-page, densely written primary source document for a class discussion. You can't read all 10 pages every time you want to make a point. What do? You take notes. You distill the 10 pages down into a small index card with just a few keywords and core concepts. When you speak in the discussion, you don't need the full 10 pages in front of you. You just glance at your index card to trigger your memory, and you can reconstruct the main arguments. MLA is DeepSeek's note-taking logic. The 10-page document, the entire conversation history, the context window. Taking notes. During processing, MLA doesn't store the complete verbose memory of every word. Instead, it aggressively compresses all that information into a tiny, latent, hidden representation. Think of it as a zip file for the memory. This index card is what gets stored in the high-speed KV cache. The class discussion. When DeepSeek needs to generate the next word, it doesn't look at the full memory-hogging history. It looks at its highly compressed note card and perfectly reconstructs the essential meaning it needs to understand what comes next. Why is this logic so brilliant? It solves the memory bottleneck. During a long conversation, a standard model's KV cache might need gigabytes of expensive VRAM. DeepSeek's MLA reduces this requirement by 80 to 90%. This means it can handle much longer texts, like an entire novel or a huge code base, without running out of memory or slowing down, and it can do it on hardware that costs much less. It's like being able to recall every detail of a 30-volume encyclopedia from a single notebook. The deeper logic, beyond the architecture. The architectural logic of MOE and MLA is what makes DeepSeek theoretically efficient, but the real magic lies in the logic of its training process. Training a mixture of experts model is notoriously difficult. The rich get richer problem is a classic failure. The router initially picks a few professors at random. They get better because they're being trained. The router then picks them even more, and the other 99% of professors are never trained and become useless. DeepSeek solved this with several ingenious training logics. 1. Load balancing logic, the no free riders rule. DeepSeek adds a rule to its training objective. The model isn't just rewarded for predicting the next word correctly, it's also penalized if the router is sending too many questions to the same small group of experts. This is a pure logic-based incentive system. It forces the gatekeeper to distribute the workload evenly, ensuring every expert gets a chance to be trained and become specialized. No professor gets to just sit in their office doing nothing. 2. Multi-token prediction logic, the grandmaster strategy. A standard AI is trained to predict just the very next word in a sentence. The cat sat on the mat. DeepSeek's logic says this is short-sighted. They train the model to predict the next several words simultaneously. It's the difference between a beginner chess player who only thinks one move ahead and a grandmaster who thinks 5 moves ahead. This forces the model to learn much deeper, more abstract concepts about language structure, grammar, and planning. If it has to predict the whole phrase Matt, it was very comfortable. From seeing only sat on the, it has to understand how sentences and narratives are constructed at a much higher level. 3. Pure reinforcement learning logic, the grind set phase. This is perhaps the most fascinating and recent development, central to the DeepSeek R1 model. The logic here is a profound bet on emergence. The researchers took a base DeepSeek model and gave it a tiny, pure, logical rulebook of rewards and penalties. Reward for a correct answer, giving the right solution to a math problem or code. Reward for structured thinking, putting its reasoning process between backtick and backtick tags. That's it. No human examples of good reasoning. No training on here's how a human thinks step by step. They then let the model grind through millions of problems using trial and error, purely optimizing for these rewards. The logic was, if intelligence and reasoning are the most efficient ways to get a reward, they will emerge naturally. And they did. The model spontaneously developed astonishing reasoning behaviors. Self-verification. It would solve a problem, pause, and double-check its own work, catching its own mistakes without being told to do so. Backtracking. It realized it was on the wrong path, said, wait, this isn't right, and tried a completely different strategy. The aha moment. Researchers documented the model pausing mid-reasoning and essentially writing, wait, let me reevaluate. This approach is wrong. I need to start over. And then it found the correct solution. It had learned a metacognitive strategy, thinking about its own thinking, purely through the logic of reinforcement learning. Conclusion. The logic of elegant efficiency. So, what is DeepSeek's logic? It is not a brute force, let's make it bigger approach. It is a philosophy of elegant, structured efficiency applied at every level. At the architectural level, it's the logic of specialization and division of labor, MOE, combined with the logic of intelligent, lossy compression, MLA. At the training level, it's the logic of fair play, load balancing, long-term planning, multi-token prediction, and the profound belief that raw intelligence can emerge from simple rules, reinforcement learning. The outcome of this layered logic is an AI that punches far above its weight class. It achieves performance rivaling the world's best models while requiring a fraction of the computing power and cost. DeepSeek's logic is a masterclass in the principle that a smarter design will always outsmart a more expensive one. It's not just building a bigger brain, it's about building a much better organized and smarter thinking brain. You can save money and improve security by running local AI models on your PC or Mac. Applications and models are available for free. I can help you get up and running. Contact me for a free demo. You need a PC or Mac with 16 gigabytes or more of memory. I have published more than 700 blogs on AI in the past 3 years. If you get value from these blogs, please join my Patreon as a member at the $2, $4, or $8 per month level. https://www.patreon.com/Steve Hovland. I have a new group on Facebook called GPT-4ALL by Steve Hovland. GPT-4 All is a free program that lets you run AI models on almost any PC or Mac. It lets you keep your private data private.